Is the moon what we think it is? The moon is widely considered to be a natural satellite of the Earth, formed approximately 4.5 billion years ago. Its composition, history, and processes have been extensively studied through scientific observations, experiments, and data analysis. Based on available evidence, our current understanding of the moon is that it is a celestial body composed of rock, dust, and ice. Hello everyone, welcome back to my channel. In today's video, we will be talking about an amazing topic that says, is the moon what we think it is? Let's examine together if you were misled or not based on what you knew about the moon or what stories you heard about it as a child. But first, if you haven't already, please subscribe to my channel and enable the notification bell so you can see more interesting videos like this. With that said, let's begin. Humanity has been governed by the rhythm of the moon's phases for eons. For instance, the length of a calendar month is generally equivalent to the interval between full moons. However, the orbit and phases of moon can seem puzzling. For instance, the moon constantly presents us with the same phase, but the amount of it we can see varies according to the moon's location concerning Earth and the Sun. Moon is a satellite of Earth. However, it is larger than Pluto with a diameter of around 2,159 miles. What if I told you that our solar system has 4 more moons that are larger than our own? Another astonishing fact is that contrary to what you may have heard, the moon is slightly bigger than 1/4 of the size of Earth, a greater ratio than any other moons on their planets. This indicates that the moon has a significant impact on our planet and may play a significant role in the emergence of life. There are many subtopics related to the moon that can be studied, including Number 1. Formation and evolution. How did the moon form and how has it changed over time? The moon is believed to have formed from a giant impact event where a Mars-sized object collided with the early Earth. The impact created a cloud of debris that eventually coalesced into the moon. The exact details of the formations of the moon are still a matter of scientific debate and investigation, but this giant impact theory is widely accepted as the most likely explanation. Over time, the moon has been changed by a variety of processes, including impact cratering, volcanism, and the gradual cooling and solidification of its interior. The moon's surface has been shaped by impacts from comets, asteroids, and other celestial objects, which created craters, basins, and other features. Volcanic activity on the moon also played a role in shaping its surface, and volcanic eruptions have left behind dark patches known as maria. A moon's interior has cooled and solidified over time, causing the crust to shrink and form wrinkles and cracks. In recent times, human explorations of the moon has also had an impact on its surface, with the landing sites and associated equipment leaving marks that will persist for many years. The moon continues to be an active field of scientific investigation, with many questions still to be answered about its history and evolution. Number 2. Composition. What is the moon made of? And how does its composition vary across its surface? The moon is primarily made of rock and dust, with a small amount of water and ice in certain regions. The rock that makes up the moon's crust is largely composed of silicate materials such as feldspar and pyroxene. The moon's mantle is also made of silicate rock, but with higher iron content, the moon's core is thought to be small and partially molten. The compositions of the moon's surface varies depending on location. In general, the highlands are characterized by lighter-colored and orthositic crusts, while the lowlands are composed of iron-rich basalts. The impact of comets, asteroids, and other celestial bodies has also played a role in shaping the moon's surface and creating areas of diverse composition. For example, certain impact craters contain deposits of valuable resources such as frozen water ice. In recent years, data from various lunar missions has greatly increased our understanding of the moon's composition. For example, the Lunar Reconnaissance Orbiter and other missions have provided detailed maps of the moon's surface composition, helping us to better understand the moon's geology and evolution. Further exploration and study of the moon will continue to add to our understanding of its compositions and the processes that have shaped it. Number 3. Surface features. What are the most distinctive features on the moon's surface and how were they formed? The moon's surface features have been shaped by a variety of geological processes, including impact cratering, volcanism, and tectonics. Some of the most distinctive features on the moon's surface include craters. Impact craters are among the most prominent features on the moon's surface. These circular depressions were created by the impact of comets, asteroids, and other celestial objects. The size and number of craters on the moon's surface provide important information about the frequency of impacts in the early solar system. Maria. Maria is a large, dark, flat region on the moon that was formed by volcanic eruptions. The eruptions produced fast lava flows that filled in pre-existing impact basins. Maria covers about 16% of the moon's surface. Rills. Rills are narrow, sinuous valleys that were formed by volcanic activity or by the collapse of the surface due to tectonic activity. Some rills are thought to be the result of lava tubes that are partially collapsed. Mountains and ridges. The moon's surface is dotted with mountains and ridges that were formed by tectonic activity, such as the formations of graben, or the uplifting of the surface due to the cooling of the interior. Tectonic faults. Tectonic faults on the moon's surface were created by the contraction of the moon's interior as it cooled and solidified. These faults have caused the surface to crack and form ridges and valleys. These and other distinctive features on the moon's surface provide valuable information about its geology, history, and evolution. Further study of these features will continue to add to our understanding of the moon and the processes that have shaped it. Number 4. Lunar missions. How have various space missions exploring the moon, and what have we learned from these missions? Human explorations of the moon began with the Apollo program in the late 1960s and early 1970s, which sent astronauts to the moon's surface and returned a wealth of data and samples. Since then, numerous space missions have explored the moon and added to our understanding of its geology, compositions, and evolution. Some of the most notable lunar missions include Apollo missions. The Apollo program sent a total of 12 astronauts to the moon's surface, allowing us to study its geology, take samples, and perform experiments. The samples returned from the moon have provided valuable information about its formations and evolution and have helped us to understand the history of the solar system. Lunar Reconnaissance Orbiter. The LRO mission, which was launched in 2009, has provided detailed maps of the moon's surface and measurements of its topography, temperature, and radiation environment. The data from the LRO has helped us to better understand the moon's history and evolution and has provided information that will be useful for future lunar exploration. Chandrayaan mission. The Indian Space Research Organization's Chandrayaan missions have used remote sensing and in-situ measurements to study the moon's surface and compositions. These missions have provided new information about the moon's mineral resources, such as water ice, and have improved our understanding of the processes that have shaped its surface. Artemis Program. The Artemis program, which was announced by NASA in 2017, aims to return humans to the moon by 2024 and establish a sustainable presence there. The program includes a series of missions that will study the mission's surface, resources, and environment, and will lay the foundations for future explorations and development. These and other lunar missions have greatly expanded our knowledge of the moon and its evolution. Further explorations and study of the moon will continue to provide valuable information about this nearest neighbor and its role in the history of the solar system. Number 5. Lunar Geology. How have geological processes shaped the moon's surface, and what does this tell us about its history? Geological processes have played a major role in shaping the moon's surface and providing clues about its history. The moon's surface has been shaped by a variety of processes, including impact cratering, volcanism, tectonics, and erosion. Some of the key geological features and processes on the moon include impact cratering. The moon's surface is heavily cratered, which provides evidence of the intense bombardment that occurred in the early solar system. Impacts by comets, asteroids, and other celestial objects created circular depressions that vary in size from small, simple craters to large, complex basins. These craters provide information about the frequency and intensity of impacts and the history of the moon's surface. Volcanism. Large, dark, flat regions on the moon's surface called Maria were formed by volcanic eruptions. These eruptions produced fast lava flows that filled in pre-existing impact basins. The study of the compositions and textures of the lava flows provides information about the moon's interior and its evolution. Tectonics. Tectonic processes on the moon, such as faulting, have changed their surface over time. These processes have caused the moon's surface to crack and form ridges and valleys, and have created large tectonic structures like rafts. The study of tectonic features provides information about the moon's interior and its geological history. Erosion. Although the moon has no atmosphere or water, its surface has been affected by erosion caused by the constant bombardment of micrometeoroids and space weathering processes. This erosion has smoothed the surface and altered the appearance of impact craters, giving us a better understanding of the moon's surface over time. By studying the geological processes that have shaped the moon's surface, scientists can learn about its history, formations, and evolution. These processes also provide clues that the early history of the solar system and the conditions that existed in the inner solar system during its formation. Number 6. Lunar effects on Earth. How does the moon influence Earth, including tides and other effects on the planet's climate and natural systems? The moon has a significant influence on Earth and its natural systems. Some of the key ways in which the moon affects Earth include tides. The moon's gravity causes tidal forces in Earth's oceans, which result in the rise and fall of ocean tides. These tides play an important role in shaping the coastlines and can have a significant impact on marine ecosystem. Climate. The moon's gravity also affects Earth's climate by stabilizing its axial tilt, which helps to regulate our planet's climate and prevent extreme changes in temperatures. The moon's gravitational influence also affects the Earth-Sun distance, which have an impact on the intensity of solar radiations that reaches the planet. Natural systems. The moon's gravitational influence affects many other natural systems on Earth, including the movements of the Earth's crust, ocean currents, and the behavior of wildlife. For example, the moon's gravity affects the behavior of migratory birds, fish, and other animals, as well as the growth and flowering patterns of plants. Overall, the moon has a profound effect on Earth and its natural systems. By studying the moon's influence on our planet, scientists can gain a better understanding of the complex interconnections between the Earth, the moon, and the solar system. Number 7. Plans for the moon. What are some current plans for further exploring and potentially using the moon, such as setting up human settlements or extracting its resources? Several space agencies are planning future human missions to the moon. These missions aim to establish a sustainable human presence on the moon and use it as a stepping stone for future missions to Mars and beyond. The moon is believed to contain valuable resources, including helium-3, a rare isotope that could potentially be used as fuel for nuclear fusion reactors. In conclusion, a moon is an important object of study and exploration with a rich history of scientific discoveries and ongoing plans for future missions. From its formations and evolutions to its impact on Earth and its potentials for resource extraction and human settlements, the moon continues to captivate our imaginations and inspire further investigation. With that being said, we have concluded today's video. Thank you for sticking with us through it, and I hope you liked the journey. If you enjoyed this video, don't forget to hit like, the subscription button, and the notification bell to get notified when new videos are uploaded from our channel. I hope the information provided was helpful. If you have any more questions, feel free to ask in the comment section. Thank you and see you soon.